Hello, and welcome to today's lesson. We're in lesson 2 of our first right triangle unit, and what we're going to be looking at today is identifying and describing what we call a Pythagorean triple, determine whether triangles are right triangles or not, and then once again applying the Pythagorean theorem to real-world situations. So now, when we look at the Pythagorean theorem, is the idea of the Pythagorean triple. If three values work properly in the Pythagorean theorem, then we know that they are the three values that create a right triangle. So when we look at 3, 4, 5, we saw that in the earlier lesson. So we have 3 squared. Let's clear everything out here. 3 squared plus 4 squared. Come on, clear. Here we go. 3 squared plus 4 squared is 25, and if we square root 25, we get 5. So we know that 3, 4, 5 is a Pythagorean triple. And notice every multiple of that is also a Pythagorean triple. So if we look at 12, 16, and 20, 12 squared plus 16 squared equals 400. Square root of 400 is 20. And we can use that with any of these other sets of values. If we look at this last set, 8 squared plus 15 squared, okay, equals 289. If we square root 289, we get 17. So all of those values are what we call Pythagorean triples. They are all possible side lengths, leg lengths with hypotenuse of right triangles. So we can also work this backwards. If the lengths of the three sides of a triangle satisfy the Pythagorean theorem or Pythagorean equation, then the triangle is a right triangle. So it's a way for us to prove whether a triangle is a right triangle or not. So if we look at these last two, are these Pythagorean triples? Okay, all we have to do is work our way through and test it out. So we clear out 25 squared plus 60 squared equals 4,225. We square root that and we get 65. So yes, this set is a Pythagorean triple. If we look at 5, 6, 7, clear it out, 5 squared plus 6 squared equals 61. Square root of 61 is not 7. So that is not a right triangle, or that is not a Pythagorean triple. So now, when we're looking at this and we're building a situation, how high on a building will a 10-foot ladder touch? We always have to draw our picture, create where is our right angle, and then fill in the measurements. The ladder itself is 10 feet. Okay, it is 3 feet from the base of the building, and we want to know how high it's going to touch up on the building. Okay, once again, hypotenuse, identify that value first. That value is going to be by itself, 10 squared equals x squared plus 3 squared. And then we just work through our algebraic solving. 100 equals x squared plus 9. Subtract 9 from both sides. 91 equals x squared. And then we can finish, if it's not a perfect square, okay, that's when we're going to use the calculator, round to a specified decimal place. The ladder will reach 9.5 feet up the building. Okay, so that's how we can always use Pythagorean theorem to help us solve situations. Okay, one of our last pieces that we're going to look at here is how can we build shapes within another object. So we have a rectangular piece of cardboard. Okay, so we're looking at this piece of cardboard that's going through the middle, dividing this box into two regions. And we want to know is what's the length of that box. So we know a box is made of rectangles. Rectangles are made up of 90-degree angles. And we're trying to find that diagonal distance C. So once again, we're looking at and going to use the Pythagorean Theorem to help us solve that. So we have 20 squared plus 30 squared is going to equal that diagonal squared. So we have 400 plus 900 equals C squared. So we have 1300 equals C squared. And then we're just going to square root both sides to get that missing measurement. So we have 1300 square root, okay, 36.1 is our C value. And if we want to find the area of that piece of cardboard, area is base times height. Okay, the base is the diagonal length, 36.1. The height is 10. So the area would be 361 centimeters squared. Okay, what is the length of the diagonal of the cardboard rectangle? Okay, we've actually found that already. That was our step 1 in order to solve this problem. Okay, that concludes our lesson for today, finding some Pythagorean triples using the Pythagorean theorem to solve some extra situations. Thank you and have a good day.